So when you go to your notebook and turn to page 8, head it with this heading, and then you might want to just split your page into four sections. A one-step with addition or subtraction, a one-step with multiplication or division, a two-step, two different two-steps, just so you have a place to take notes. We're focusing on solving equations, and we've talked about solving equations a lot. It means to find the value of the variable. So when you plug in that value, you're going to end up with both sides being equal. We often use opposites to find the value of the variable. So if there's addition in the equation, we might subtract to find the value of the variable. That's what opposites means. The opposites are addition and subtraction, multiplication and division, squaring something and square rooting something, etc. So here we're dealing with finding the value of the variable. We want to find the value of x, so we want to get rid of the 5. You can probably figure out the value guessing and checking, but here's where we talk about opposites. We're going to get rid of this 5 by subtracting 5 from both sides. Oh, come on. We're going to subtract 5 from both sides. You can always also thinking about it as adding the opposite of 5, because it's an opposite thing. So here on this side, 5 plus negative 5 is 0. Zero's out, we end up with x is equal to negative 8. If I put the original equation with my solution, I can plug it in, and sure enough, 5 plus negative 8 is negative 3. It works. So, enough. This is also one step, because it's really only negative 5 minus x, but it's confusing because you have to deal with that minus x. Here, though, still, we want to go ahead and deal with this part first. So we're going to do the opposite. So here's you can think of it as subtract 5, you can think of it as a negative 5. We're going to go ahead and add 5 to undo it on both sides. And that zeroes out on this side, and then we get the opposite of x is equal to negative 3 plus 5. There's more positive, so it's going to be a positive 2. Now, a lot of people are having problems with this symbol. I read it as the opposite of x is 2. So that means that x has to be negative 2. But maybe that's not working for you. So let's think about it this way. Think about it as negative 1 times x is 2. Then you have to go ahead and divide both sides by negative 1, and you can end up with x is negative 2. We plug it back in. Let's go ahead and do that. Let me get rid of everything for a second. We found out that x was negative 2. So we go negative 5 minus, and we plug in negative 2 is equal to negative 3. Remember, subtracting a negative is the same thing as adding a positive, so it's negative 5 plus 2. Sure enough, negative 3 equals negative 3. So remember, your solution is going to make the equation true. Here we have a multiplication problem. Remember, anytime we have a number smashed up next to a variable, that means multiplication. So it's just like there's a dot in between. Whoops, it's the wrong color. I'm not going to be able to see that. There we go. 5 times x. And so we're going to get rid of that multiplication with its opposite, which is division. So we're going to divide both sides by negative 5. And x is going to be, let's see, 15? Nope. 13? 85 divided by 5 is 1. We get 5, we get 35, 17. Okay. We have a negative divided by a negative, so it's going to be a positive 17. Here we have a division problem. This symbol means divide. So some number divided by -4 is equal to -8, so we can go ahead and find the missing number. If you don't recognize right away that it's going to be 32, then you just go ahead and multiply both sides by -4. This -4 and this -4 cancel each other out, divide each other out, so all that's left is a 1x. You can write the 1 or not. -8 times -4 is 32. So x is going to be 32. Sure enough, 32 divided by -4 is going to be -8. It checks out. So when you're dealing with two steps, and here we've got a variable that we want to find the value of, but it's 5 plus 2 times some number is equal to 7. You can guess and check that. You can figure it out. But if you can't figure it out with guessing and checking, you can always use opposite operations. But some people don't know where to start. I'm telling you, this is what you want to think about. Solve using backwards order of operations. So you're going to go, okay, backwards order of ops, that means the last thing I'm supposed to do in order of ops is addition and subtraction. So that's the first thing I'm going to deal with here. So we're going to go ahead and we want to get this thing by itself, but first we're going to deal with this thing. So we're going to subtract 5 to get rid of it. That's how we're going to start. And we get 2x equals 2. And at this point you could probably figure out that x has to equal 1. But if you don't know, you can go ahead and say, okay, I have a multiplication problem. I'm going to get rid of that by dividing by 2. So x is equal to 1. And sure enough, if we go back and look at our original problem right here, and I go, okay, I'm going to take my 1, and I'm going to replace x with 1. 5 plus 2 times 1 is 5 plus 2 is 7. Sure enough, x is 1 is the solution. So here again, we're dealing with a two-step equation. We want to get a better understanding of what this has to be, right? We want to know what x is, but we can think about x divided by 3 has to equal 3. And that's one way of thinking about this. You can kind of chunk that up, or you can go ahead and use opposite operations. And if we're going to use opposite operations, we're going to go ahead and look at using the order of operations backwards. So we're going to start with the addition problem piece that's separate from the variable. So we're going to go start with the whole. And so to get rid of that 4, it's a positive 4, so we're going to subtract 4, wrong thing. Subtract 4 or add -4. So we're going to start with the number without the variable. So once we've done that, we get 3 equals x divided by 3. Probably can tell at this point that x has to equal 9, but if you didn't know that, we have a division problem. So since it's division, we're going to multiply by 3 to get rid of that divide by 3. So multiply by 3, multiply by 3, and we get 3 divided by 3 is x. 3 times 3 is 9. And then we go back to the original problem. We get 7 plus 4, 7 equals 4 plus 9 divided by 3. 9 divided by 3 is 3. 4 plus 3 is 7. Sure enough, here it works. So the idea is when you have a two-step, go ahead and think about dealing with this number that's on the same side as the variable, but not with the variable first in addition and subtraction. So for a lot of people, what confuses them about solving equations is not the equations or the opposite operations. It's, I don't know what to do because it looks different or weird. I want to give you permission, if you can figure out an easier way to write the exact same thing, do it. So in this particular case, we've got this 5 minus x equals 10. You don't like that? Write it another way you can think about it, which is 5 minus 1 times x equals 10. Or maybe you don't like the subtraction at all, so you're like 5 plus a negative 1 times x equals 10. Maybe these are all equal to one another. And then one of them might look easier for you to deal with. Here we've got a division problem, the opposite of x divided by 5, but that opposite of x thing some people get confused about. So once again, make it a negative 1x divided by 5. It's the same exact thing. One of those invisible ones in algebra. Or it's also the same thing as negative 1/5 times x equals 2. Equal. Whichever one is easier for you to deal with is just fine. This last one here. We have 11 minus negative 2x equals 9. Often we see that parentheses put there to make sure we know it's a negative 2. But most people don't even like to deal with that subtraction, so they are like, okay, it's 11 plus positive 2x equals 9. Much easier for me to deal with. That's how I deal with that one. So remember, things might look different, but they're really the same. Okay. Shoot. I've done something.